We recently attended the Tiny House Festival in Vermont, where my good friend Bill Hulstrunk gave a wonderful presentation about wall systems that you can use for tiny houses. This video I created with his permission, and it is his presentation, which I've compiled with his slides, so I hope you enjoy.
Let's see if we can get there's a couple different ways you can actually frame up or build your tiny house walls. One is stick frame, that would be with either wood or metal. There's some advantages and disadvantages of both, and we'll take a look at them. Would be using the SIP panels, the structural insulated panels. And typically those are foam filled with a skin on the outside that's acting as the structural element for the walls. We'll talk a little bit about, again, some of their advantages and disadvantages. In comparison to SIPs versus stick frames, if you're looking, SIPs are stronger just because of the way that they're built. They're all integrated and they're kind of tied together a little bit more. So it tends to be a little stronger on that. Weight, you'd think that SIPs might be a little less weight, but actually the folks that have put together their tiny houses have found that frame typically is a little bit lighter stick frame than a SIP panel. Costs, the SIPs are going to be more expensive. They're going to be pre-manufactured, but on the other hand, they're going to be able to go together quicker because basically you're just screwing some panels together instead of framing up the entire building. The electrical, if you're going to change things down the road or modify things, first of all, the electric's a little easier with a frame because you're running it through the studs itself. With the SIPs, you'd need to route out some new channels or do some surface mounting if you're going to change where your electrical locations are. And then in terms of insulation, SIPs can also have a little bit more insulation. Sometimes they're a little bit thicker, and we'll get into some of the couple different insulation systems as well. Next slide. So wood or steel? Well, in terms of weight, structural steel frame can be 40 to 60% lighter than wood. So weight sometimes is an issue. Maybe it's your trailer has a maximum weight rating on there. So sometimes steel can be good for that. But in terms of cost, wood is typically 2 to 3 times less expensive than steel. Just because the availability, you're putting it together, maybe a little bit, putting it either easier to put together. A lot of the structural steel frames, people are buying basically the frame and then building the house up from that. And that's going to certainly add to the cost a little bit. Flexibility, if you need to reposition a window or you need to change kind of the structure itself, wood is a little bit easier to do the modification than a steel, particularly if you have somebody prefabbing the steel system on that. In terms of energy efficiency, we have to remember steel is very conductive. And kind of the rule of thumb is if you put your insulation into the cavity of that steel frame, you're going to reduce the insulation by half. So that's a pretty big downside. So typically when we're doing steel frames, we'll actually be looking at exterior insulation systems like some exterior foams or board rock wool panels would be another option for that. And when we talk about structural steel, again, we're talking about something different than if you go down to Home Depot or Lowe's and purchase the steel layer. There's a couple folks here with some steel frames here you can take a look at. Those are pretty beefy in comparison to some of the other ones you might see. When we're building these things, we have to remember, think about this is your wall system and your roof system and your floor system as well. They're all kind of layers that need to go on there. So we need to control, we need to keep the rain from getting into our siding. We don't want things to be rotted out. Oh, sorry. We don't want things to be rotting out. We may need to be taking into account vapor or condensation, and that will depend on the type of insulation we might be thinking to use it. Air leakage, we don't want the thing to be drafty and we want it to be more energy efficient, so we want the envelope to be as tight as possible that way. We're going to be putting our thermal insulation either inside the frame or outside of the frame, depending on our insulation system. And then we're gonna, want to make sure we have a ventilation system because, we don't want to create problems. We're thinking of, I want a real tight, energy efficient envelope here for comfort and energy use, and yet I want a healthy indoor environment by having our active ventilation system. The tiny house, as all houses, we need to work kind of as a system. Bulk water control, we're going to make sure that we got flashing and drip edges on our walls, around the windows and door, and other openings there. We're going to use some tar paper or house wrap on the other side as a rain screen. So the rain screen is any water that gets through our siding will have an ability basically to run down the side of the building without getting into the frame, getting into the sheathing and rotting things out over time. And then we're going to back vent our siding. We have some products over here. If you take a walk around, you see these kind of fuzzy looking outside black things on the outside of the building. That's the rain screen. That gives a capillary break so that when water comes through, water will come through that siding at some point. It now has a pathway out. Vapor control, so this depends on the type of insulation we're using. So if we use glass-based insulation like fiberglass or mineral fiber, we have to think about vapor control. Because if we don't do that, we're going to have problems with interior moisture going through our insulation, hitting the exterior sheathing and condensing. If we're using something like cellulose, which it's hygroscopic, the cellulose has the ability now to disperse this moisture and not let it form on the outside. So if we're looking at fiberglass or rock wool, we have to think about putting a vapor retarder in there. Otherwise, we're going to have some durability issues over time, particularly in cooler weather. Air leakage control. So again, we don't want drafts coming in the winter time when the wind's blowing there. We also we want a nice tight building with air leakage control because we don't want uncontrolled air leakage bringing moisture to areas where it potentially could be condensing and then turning into rot and mold over time there. So the easiest method we found for creating an airtight building assembly is actually to air seal the exterior sheathing because there you have the least number of joints. So again, you're going to be doing your air sealing typically from the outside of the building before you put on your maybe before your rain screen, maybe even before your building paper if you're using plywood or OSB. And typically you're going to be using some of these real high quality tapes that use an acrylic adhesive on it. And you're going to be applying these at the joints or the seams of the building before your siding goes on. And then you're going to air seal the other cracks with caulk and gaps with a foam gun. Again, making that envelope as tight as we can be. So air sealing is all about connecting the dots. Again, we want to make sure that before we cover this up, that all of those seams are. We're actually going to also make sure that we tape it around the corners of the walls and the wall to the roof and the wall to the floor. We want all those connections kind of be all the way around. We want it to be continuous from the top all the way to the bottom. Insulation options. So you could have bats, boards sprayed on, blown in. So it's very difficult to actually achieve good cold weather performance and actually really hot weather performance with bats. And I'll talk about convection a little bit here. So, but it's a real issue. We've done a lot of work with the infrared camera, and on a cold day, it's not uncommon for your wood element in a wall to actually outperform your insulation because of this convection that's going on there. Rigid board products like foam or rock wool board, when we're putting those on, we also want to be air sealing or making sure that those connections are nice and tight. There's no gaps around them or under them where we could get convection actually bypassing our insulation there. And then there's blown in or sprayed on insulation. So this would be like blown in dense pack cellulose or spray foam, spraying on open or closed cell foam. Real quickly, the problem with convection is whenever we use a bat, what we find is that in the winter time, we got warm air on this side, it heats up the air kind of at the interface between the bat and the inside wall. It starts to rise, air becomes more buoyant. You have the same thing going on that cold air side. That creates that kind of convective loop around there, which is basically bypassing your insulation. And when it does that, you're not getting the performance out of that. You're going to have issues. You can also transport moisture and other things kind of around that. So bats are just not not the best option for this. Even if you try to install them really well, there are some issues with that. Some of your insulation decisions are your insulation value stable over time? A lot of these foam products use these inert kind of lower conductivity gases. But unfortunately, these things do kind of seep out or leak out over time. So they experience what's called thermal drift on it. Also, can your insulation, help to increase the tightness of the building? Some of the denser products, like the foams and the dense packed cellulose, actually will slow down or actually prevent air leakage from getting into the building. I don't want to say that they're always the perfect air barrier, but they can certainly help the tightness of the building. Does it improve fire safety? The one issue that I'm a little concerned about these days with some of the foam products in particular is they are very fire, they produce a lot of toxic combustible smoke. So if you're using foam in these buildings, we have to make sure that we have a 15-minute barrier in front of them in order to kind of give you some protection inside the building. The nice thing about the tiny house certainly is you're not too far from, hopefully, the doorway there. So I do a lot with dense packed cellulose. It's just proven to be just something that's very, very reliable. It's very stable over time. It's certainly definitely a cost-effective way to enhance or build some higher R-value buildings. We've used them in a couple of tiny houses, including a super insulated tiny house I'll show you. It also resists insects. It's compatible with other building materials. We talked about the hygroscopic properties of it. High recycled content, low embodied energy. Next slide. So if you're going to do cellulose, then you'd basically be using a machine such as this. If you're lucky enough to live in Vermont or New Hampshire or even northern Massachusetts or Massachusetts anywhere, we have availability of these machines. In fact, this particular manufacturer, no matter where you are, will rent you a machine to do this. And basically what it involves is stapling up this material called Insul Web, which looks like the material underneath your box spring or your sofa if you lifted it up. And then you're going to basically be injecting the cellulose in, and call it dense pack because you're putting it in at 3.5 pounds per cubic foot. And at that density, the material is truly self-supporting and will not settle over time. And then afterwards, we're just going to roll that fabric flat, and then your wall covering can go up over the top of that. Here's a super insulated tiny house up in Marlboro. This is how we typically handle the roofs on those homes, and the walls themselves were built out. So it was a double stud wall on the walls and the roofs. But this proves that even in a little teeny house, don't be afraid to insulate it well. In summary, here we want to make sure that the building envelope controls all of the things we need to control. We need to control, bulk water from coming into it. Depending on our insulation, we may need to be talking about vapor. The air, we need to make sure that we don't have uncontrolled air movement coming in there. The insulation is going to provide our thermal and then our ventilation system. And in terms of our air barrier, we need to make sure that it is continuous. So if you have your tiny house design there, one way to do it is take your pencil and draw around the insulation layer around the entire building, and then go ahead and draw where your air barrier is all the way around. And make sure that they're all connected. And the critical thing that we found when we're looking at buildings is that air barrier and insulation needs to be in direct contact with each other. So no air spaces, because in these air spaces, that's typically where you're going to get air leakage coming in, and it's going to bypass your insulation. So some of the takeaways are, you got to absolutely be sure that your insulation and air barrier are in direct contact with each other. They cannot separate. If they separate, you're likely not going to have any good insulation performance. Also, we found that air sealing materials and your insulation materials, a lot of times, if they're more flexible, they're going to be more durable over time. Again, you may be moving this house around, and if you have something that's very, very rigid in there, you're more likely to see things cracking or kind of breaking as a thing is moving around. So when you're looking at air sealing materials, just look for things that seem to have maybe a little stretch to them or a little bit of a give to them, a little bit better. So a little bit about insulation. So in terms of R value, because that's something a lot of people think about. I want the insulation that has the highest R value. Well, the highest R value are the foam type products. Closed cell foams typically have the highest R value per inch. Some of the issues with closed cell foam is sometimes they tend to be pretty brittle, and I've seen them after the frame shrinks a little bit, you actually will crack or break, they'll separate from the frame, and then you could have that convection going on there. As you come down from closed cell foam, the next one would be, in terms of high to low, you'd be getting into those things like extruded polystyrene, XPS, which has or actually polyiso, which is kind of that tannish kind of foam. Typically has a foil facing on each side. That has an R value of about 6 per inch, maybe a little higher than that. That product also experiences some shrinkage over time, and you may have read about it if you're looking at insulation systems. Next would be extruded polystyrene, or XPS. That would be blue board, pink board, green board. That has an R value of about 5 per inch. Below that would be expanded polystyrene, which is 4 per inch. Or actually somebody here with that micropore, which looks like your styrofoam cup, but it's kind of grayish looking. That has graphite added to it, and they're saying that R value is a little closer to 5 per inch. We like the expanded polystyrene if you're going to be using foam boards, because that has it's least detrimental to the environment when those things are produced. The closed cell foams and the polyiso, unfortunately, have they're pretty bad in terms of their manufacturing. From that, then you get down into kind of the dense packed cellulose, 3.8 per inch. The mineral fiber boards are kind of in that same area there. And then the fiberglass is below that. So if you can avoid using fiberglass, it works better. And even the blown-in fiberglass, the issue with that is if you hit a bump in the road, what happens with it is it tends to move down a little bit, but it doesn't have that springiness to basically keep it in place that the cellulose fibers tend to work a little bit more. I want to just do a quick thing. If you're looking you want more information, this is kind of an interesting subject to you. I do teach a super insulation for net zero buildings at Yestermorrow, and it's coming up in July. And if you live in the Burlington area, actually there's some help with the tuition on that might be helpful to some folks. I think we can take some questions.
Yeah, we have a few minutes for questions.
Okay, great. Anybody have any questions? Yes.
I've been looking a little bit into steel insulated panels. They're like the zips that got the thin steel inside. Just wondering if you have any input on applications in tiny houses.
Yeah. So
Bill, will you repeat the question?
Yeah. So the question was you were looking at some panels that had actually steel on the outside of them and foam on the inside. You see these in terms of a lot of industrial coolers and things like that. The one thing to ask those folks is if the panel-to-panel connections, are they steel or are they foam that kind of go together? If they're steel, that would be typically a thermal bridge on that. And also, if we're dealing with SIP panels, they have a channel in the middle that they inject foam into. But I would always want to also put a secondary air seal of that tape on the seams. But I think that could be it. Those panels have been around for a long time. I think that could be a good option. Yes. Yes.
And how does wool insulation fit into these?
Yeah, so I've been waiting for somebody to make a blown wool product, and I've yet to see that. I've seen wool bats, and unfortunately wool such as fiberglass and mineral fiber, or even a cellulose bat, they're all going to unfortunately have that issue with convection. So if they had a blown-in wool product, I think that could do a better job with that. Yes?
What about dense packed fiberglass versus Cellulose.
Yeah, so again, some of the issues. So first of all, with dense packed fiberglass, you're going to need to have a vapor retarder because the material is hydrophobic. Moisture will go right through it and potentially condense. And again, there's the issue of if you're moving that house and things bump. I've seen it where the fiberglass will actually you'll get a gap between that and let's say the top plate. And the fiberglass doesn't have the ability basically to push itself back out. You may, if you're thinking of going that way, go with a really high density fiberglass. It would have to be over 2 pounds per cubic foot in order to do that. Yes?
You mentioned about how insulation things external cracks. How come you have to just strip it all out? Or
Yeah, so if you have foam that's, let's say, inside the cavity of the wall. Oh, I'm sorry. So if you have spray foam that cracks in your wall, what do you do to take care of that? So because it's inside the wall, a lot of times you won't know that there's a problem. But in order to fix that, you typically would have to either take that out and refoam that, then put it back on. So I kind of think of things as the walls of the building are the things that are going to be around for a while. So make sure that you spend a little extra time on your insulation system. Your mechanical systems, you're going to probably be changing out because they're going to, but the walls, the insulation of the building, that's something that typically is going to be there for the life of the building.
That should be, let's see. Let's give Phil a hand for all his information. And let's get a picture of the dress.